one more example. Let's say I'm creating teams for, I want to call it doubles basketball, but that's ridiculous. Let's say I'm creating some sort of sport where we're going to put a girl on a guy's shoulders, and they're gonna, I don't know, do anything from try to knock each other over in a pool to play basketball, and we want to know what their heights are going to be when combined. So here I'm adding two random variables, or subtracting them doesn't, well, adding two random variables, but they're different from each other. That's what I want to show, when they're different from each other. What happens when they're added together? These are continuous random variables. I'm not going to give you all the possible results, but we know that the average boy's height is 68 inches, 5'8", and the standard deviation on that is 2.5 inches. Average girl's height, just the extra height that she adds by sitting on his shoulders, is 29 inches, and the standard deviation of that is 1.6. So, question is, what will the expected value of their combined heights be? What's the expected value of x plus y? And what is the standard deviation of x plus y? Well, the expected height would be just add their combined, the height of the guy plus the extra height added by the girl, and we get 60, 80, 97, right? But the standard deviation is a messier thing, because we can't add standard deviations. Standard deviations are handy facts, but they're not mathematically valid things. What is mathematically valid? Variance. So I should really calculate the variance of each one. I can add variances. I'll take 2.5 and I'll square it to find the variance in boys' heights. I'll take 1.6, which is the standard deviation of girls' heights, and I'll square it to find the variance of the extra girls' heights. And when I add those together, what I'll get is the new variance, the variance of that. So that'll be the variance of x plus y, but I don't want to know the variance of x plus y, I want to know the standard deviation. So I will square root each side. And if this looks an awful lot like Pythagoras, it's because the math is exactly the same. We would square one standard deviation, square the other standard deviation, add them, and then square root the result, so that we will find the new standard deviation. So 6.25 plus 2.56 comes out as 8.81, then we need to square root that, and that'll come out as, who knows what, let's find out. 8.81 square root, yeah, it's 2 point. My point is that we do not add standard deviations when combining two different random variables. We basically use Pythagoras. Yeah, root 2, which I used in a video or two ago, was basically like a special triangle, and both of them are the same. Then, you know, it's root 2 for the hypotenuse. Sorry, if you understand that, great. If you don't understand that, don't worry, you don't need that. But the point is, when you have two separate things, and you're combining them to find the new standard deviation, well, you can't add standard deviations. What you can do is add variances. So you'd figure out what the variance in each one was if they didn't give it to you. In this case, I didn't. I just gave you standard deviation. The variance of each height. And then you could basically find the combined variance and square root it to find the combined standard deviation. So if I paired random boys with random girls, and the random boy's height had those facts to them, and the random girl's extra height added had that random stuff to it, then my teams would average 97 inches tall with a standard deviation of about 3 inches, plus or minus.